reactivity for SN2 reaction is inversely proportional to steric hindrance. So, smaller the alkyl halide, better will be SN2. So, methyl halide shows a better reactivity than a 1 degree halide, then a 2 degree, then a 3 degree. So, 1 degree halides are more reactive towards SN2. Similarly, we can say 3 degree alkyl halides are more reactive for SN1. Now, among fluoroalkanes, chloroalkanes, bromoalkanes, iodoalkanes, I think you will agree with me that carbon iodine bond is a bigger bond and a longer bond, so it is weak, so it breaks easily. So, iodoalkanes are more reactive than bromoalkanes, then chloroalkanes, then fluoroalkanes. Fluoroalkanes bond is a smaller, fluorine and carbon, fluorine atom is a smaller atom, so fluorine carbon atom is a small bond, so it is very strong. So, fluoroalkanes hardly react, but iodoalkanes give a good reaction. So, bigger is the bond, weaker is the bond, more reactive is the bond, right. So, RF, RCl, RBr, RI reactivity order increases. Now, coming to SN2 reactions, if I show you what actually happens, it will be something like this. We have SN2 mechanism. I will take methyl iodide something like this. Here, if we take a nucleophile, Nu minus, then what happens is this nucleophile attacks from the backside. It comes from the backside, and this iodine and nucleophile together will form a transition state. Something like this forms, where nucleophile is at the backside and it is forming a partial bond, not a complete bond. So, nucleophile is coming in, at the same time nucleophile is coming in, and at the same time halogen bond is breaking up. So, this is known as a transition state. This is known as transition state. Transition state exists. Then what happens is this halogen is removed and nucleophile is attached at the back side. So, we get the product something like this, and other bonds are completely inverted like an umbrella in a strong wind on a rainy day. If you have an umbrella and the spokes of that umbrella will turn towards upside when strong wind is blowing. Similarly, what is happening is these hydrogen carbon bonds were at the back side. When nucleophile is attacking from the back, these bonds will flip and become exactly opposite of their position. So, what is happening is this older bond was on the right side and the new bond is on the left side. So, this thing is known as Walden inversion. Walden inversion. If I have to write a rate law equation, so how I will write this is rate of SN2 is directly proportional to the concentration of alkyl halide and the concentration of nucleophile. So, the order of the reaction is, order comes out to be 1 plus 1 because the powers are 1. So, order comes out to be 2. So, it is a second order reaction. We have two reactant molecules, one is nucleophile, one is alkyl halide. So, two reactant molecules, that is why the reaction is bimolecular reaction. That is why you are having this 2 over here, because we have two reactant molecules as well as order of the reaction is 2. So, it is a second order reaction and a bimolecular reaction. Next is, less is steric hindrance, more will be reactivity, because of which methyl halides are more reactive than a tertiary butyl halide. So, this is it for SN2. Thank you.